Hello everyone, and welcome to OneClass. My name is Jeff Krause. I have a PhD in chemistry, and today I'm going to run through a few undergraduate, high school level chemistry questions. So here's our first one. Draw Lewis electron dot diagrams for the following species. So here's our first. First on the list here is arsenic trihydride. So if we check in the periodic table, arsenic is underneath nitrogen. So this guy has 5 valence. And this guy always has 1 valence. So times 3 is equal to 3 total. So then the total valence electrons are 8. So the way I always draw these is just to hope at first that it follows a simple pattern. And then to correct afterward if not. And so this looks good. So it'd be a trigonal pyramidal structure where the wedges are out of the board and the dashes are into the page. So that'd be a trigonal pyramidal. Okay, and then I guess it's just electron dot diagrams, but oh well. Okay, so then HOCl, we've got 1, 6, 7 for each of the valencies, so then 14 total. Okay, and then again I'm just going to assume simple and then correct afterward if it doesn't work. So that looks good. And we've got our 2, 4, 6, 8, 10, 12, 14, so that looks good. And so that's our molecule. It's linear. Okay, and then KrF plus, krypton has 8, fluorine has 7, and then the plus charge is -1. So -1 of our total electrons, so 8 plus 7 is 15, -1 is 14 total. And then in this case, I would say it's fairly obvious that for krypton to bond, we have to take an electron away from it. So I'm going to give it 7 instead of 8. And then for fluorine, I'm going to give it its full 7. There's its bond. And then if we check the charge here, we count the number of electrons around krypton. Well, it's 7, which means it has a plus charge. So that would be krypton, fluoride, with a positive charge on the krypton here. Okay. PO2, Cl2 minus. Okay, so then we've got 5 electrons here. 6 times 2 equals 12 there. 7 times 2 equals 14 there. And then the minus charge is going to be another +1, so an extra electron. So now we've got 5 plus 1 is 6, plus 12 is 18, plus 14 is 42. Wait, what did I just say? 5 plus 1 is 6, sorry, plus 12 is 18, plus 14 is 32. There we go. I don't know what kind of weird math I was just doing. So we should have 32 total. And it gives us that the phosphorus is the central atom. So again, I'm just going to kind of assume that things are going to be simple and then correct afterward. Except we need 4 bonding partners. So I'm going to go ahead and give our phosphorus its 4 bonding partners. And then put our oxygens in around it the way they normally would be. And see what needs extra electrons. Okay, so at this point now, we've got our single bond here, our single bond here. If we count our electrons up, we've got 2, 4, 6, 8, 2, 4, 6, 8, so that's 16 over here. And then we've got 2, 4, 6, 7 here, and 2, 4, 6, 7 here. So there's 14 over here, so that's 30, so we're missing 2 electrons. So we could go ahead and just plunk them here and here, which would give us our bonds here and here. Okay, and then now we've got a negative charge here, a negative charge here, because if we count the number of electrons around oxygen in both cases, it's 7, but oxygen normally wants 6, so that's a minus charge. And then if we count the electrons around phosphorus, then it's 4, and phosphorus normally wants 5, so that's a positive charge. But we've got full octet everywhere, so that looks pretty good. The only thing that I will point out is that phosphorus can become hypervalent because it's lower in the periodic table, meaning octet doesn't matter that much. And so this structure might actually be more plausible, even though the octet rule is not satisfied. But because in this structure we now have the negative charge, we now only have a single negative charge on the phosphorus in the center, and therefore the charge isn't distributed or split across the molecule in such a great amount. But in any case, both of these structures are viable, I would say. Okay, let's check through the solution here. So there's arsenic trihydride, which basically is what we had. It's a little drawn funny, but it's okay. HOCl, just backwards from how I drew it, but that's the way we did it. KrF plus. That's just kind of wonky. There's 2, 4, 6, 8, 10, 12, 14, 15 electrons here. But KrF plus should only have 14, so that's just incorrect, I would say. As there's not the right number of electrons. We've got 2, 4, 6, 8, 10, 12, 14, 15, but as we already counted, we need to reduce the electrons from 15, which is the normal amount, to 14. So that structure is just not correct. And then, well, the fluorine. It's got fluorines instead of chlorines, but that's okay because they basically have the same valence. I think that is a viable structure. Yeah, I could have drawn that as well by looking at it, because we could have. This is basically popping this up, which actually should be another viable structure in retrospect, because we've still got the charge. We still got the charge localized on only one atom. It being oxygen. Yeah, so that would be fine as well, actually. Phosphorus is still hypervalent because it has 10 bonds, but that's fine. And the charge is only on one atom, so I would think would be happier than in this fully charge separated case. So it's just the fluorine should be carbons. I'm going to have to say it's incorrect though, just because the KrF plus solution. So has too many electrons. Also PO2Cl2 structure uses fluorines. So I'm just gonna say it's incorrect because the FKR, or the KrF solution there.